Okay, so today we're going to review scientific notation, how to put it into scientific notation, a standard number, and how to take it out of scientific notation, which would be putting it into standard notation, which is, just a regular number, the way we're kind of used to looking at it. So scientific notation is a method of writing small and large numbers using a base of 10. A small number simply means a number smaller than 1, and a large number simply means a number larger than 1. So they don't have to be large and small, don't think of it that way, but it is more useful if they are larger, much larger numbers and much smaller numbers. It makes a little bit more sense to actually convert them between scientific and standard notation. So we can see here, so decimal to scientific notation, and decimal, another way to say that is standard notation. So keep in mind, Alex will use that wording. You're going to move the decimal point right or left to arrange one digit to the left of the decimal point. So remember, there needs to be one number when you're taking it from standard notation to scientific notation. There needs to be one number in front of the decimal. So you can see it's 5 point, 3 point, 4 point, 6 point. So a number between 1 and 9. It can't be 0 and it can't be bigger than 9. So you can't go 10, 11, 12. It has to be somewhere between 1 and 9. So one digit. Okay. So with this one, we can see that there's 52,314. And to put this into scientific notation, I'd have to take the decimal place, which is at the end here. If you don't see decimal, it's always at the end. And I'm going to move it 4 to the left. And so I have 5.2314. So none of the digits dropped away. These are all essential numbers. There's no zeros here. So all the numbers are still present. Times 10, and I note that I moved it 4 times to the left, so I'm showing that with an exponent here. Okay, so 3.2, this one, you're not going to actually move it anywhere because it's already it has one decimal point here, 3.2, so it'd be 3.2 times 10 to the 0 power. There's really no point to convert between scientific or standard because they're really the same number. They're the same number anyway, but this really doesn't change anything, converting 3.2 from standard to scientific. This third one here, we have 0.0000428. So this is a very small number, right? That's a decimal point here at the left side. So we're going to take this decimal point and we're going to move it until we have one number to the left of the decimal point. So I want it to be 4 point. So I know I'm going to move it right here. So that's 5 places to the right. So that's 4.28. I dropped off all these zeros. It's just 4.28 times 10 to the negative 5. And I'm going to go through and I'm going to explain a little bit more about the positive and negative. So hopefully that'll make a little bit more sense because I know sometimes it seems a little backwards when we're doing this. So this one we have 602 million. And we're going to take that decimal that's on the right side here. I don't see it, so it's automatically here. And I'm going to move it all the way over here so that it's 6.02. And again, if you notice, I can drop off all these zeros. I can't drop off the 0 that's between the 6 and the 2. That's an essential number. Okay, but these zeros I can drop off. They're non-essential zeros. I don't need them once I put it into scientific notation because I'm noting that I moved 8 places to the left. Okay, so let's take a look at why we do negatives and positives. So first, let's think of a number line. So we have a basic number line. No, I didn't put any numbers on it. We're more focused on the directionality. So if I go to the right, that's positive. And if I go to the left, that's negative, right? Well, I'm not really focusing on necessarily the numbers. And I don't necessarily mean when I go to the right, I'm going to land on a positive, or if I go to the left, I'm going to land on a negative. What I'm talking about is the direction. If I'm going to the left, then I'm going toward the negatives. If I'm going to the right, I'm going toward the positives. Okay? So to put it into scientific notation, we take note of the direction the decimal is moved from. Okay? So what I mean by that is if I have a number like this, where it's 0.0005, we're going to move the decimal from the left. You can see that red arrow happening here. So it's a negative exponent because I moved from the left. So it's 5 times 10 to the negative 3. The negative exponent actually tells me that it's a small number. It tells me that the decimal came from the left. Okay, so if I have a number like this, that's 5,000. Well, now I'm going to move that decimal from the right because it's at the end here. So I'm going to move it from the right. Since I'm moving from the right side, that's a positive exponent. Okay, so it's 5 times 10 to the third power. That positive 3 tells me that it's a large number, that the decimal came from the right side. Okay, so this is how to put it into scientific notation. Now, if we take those same numbers and we're going to take them out and put them in standard notation, we still have the positive and negative from the left and the right. But now we're going to put it into standard notation, and we're going to take note of the exponent to know which direction to move the decimal. Okay, so now if I have 5 times 10 to the negative third, which is just the one we had just done, well, it's a negative exponent, which means that the decimal move the decimal to the left. Sorry, funny reading there, because it's negative exponent. So that's left. Okay, so I take the decimal that was here, that's where it is on the 5 here, and I move it 3 times. And now I have to put the zeros back, and if you notice there is another 0 here on the front, that's the proper way to write a decimal. So Alex will kind of give you grief if you don't have the 0 in the front. It's not necessarily wrong, but it's going to give you grief about it, and eventually it may mark you wrong because you're not putting it in, the kind of standard decimal format. So now if I have 5 times 10 to the third power, they look identical, except that I have negative 3 and I have a positive 3. So that positive exponent means move the decimal to the right. So I have that decimal that's right there again, right after the 5, and I'm going to move it over here. And again, standard way to write a number is every 3, I'm going to put a comma in there to separate out my thousands. So it's every 3. It's not just thousands, it's thousands on this one. But make sure if you don't put the comma in, again, Alex may give you grief about it, but it shouldn't necessarily mark you wrong. As you move forward in math, though, it may start to mark you wrong because it's going to expect you to understand how to write it in, a standard number format. All right, so let's go ahead and take a look at a few of these. So we have write 8 times 10 to the third power in standard notation. So we're taking it out of scientific notation. So this is where we're going to look at the exponent to tell us where to move, okay? So on this one, we have a little fill in the blank here. So numbers in scientific notation, a positive exponent means a number larger than 1. So move to the right using an exponent as the number of times moved. Or we could have had a negative exponent, which means we have a smaller number than 1. So move the decimal to the left using an exponent as the number of times moved. So since we have a positive exponent, we're going to do this first one. So I'm going to take that 8, and here's my decimal point, right? It's right after the number. And I'm going to move it 3 times to the right. 1, 2, 3. And now I have to fill in those spaces with zeros and make sure that decimal is no longer there. We moved it over here. But I do want to put that 1,000 separator in there so that I have my standard format there. All right, so now we're going to write 651 in scientific notation. So we have a number larger than 1 means a positive exponent. Move the decimal to the left and count the movements as movements as that will be your exponent. Or a number larger than 1. This should be smaller. Darn it, that's a typo. Smaller than 1 would mean a negative exponent, and we would move to the right. So I'll fix that. But this should be smaller, negative, right. That was just an oops typo on that one. So we are, in fact, using that top one. So we're going to have our number here. And again, you can see I put the decimal point there so you can see it. We're going to move it back until we have one number. So I'm going to go 1, 2. So I have 6.51. And then since I moved it 2 times, and we're putting it in scientific notation, so we're looking at where is it coming from. It's coming from the right side, so it's a positive 2. Again, it was a larger number. I made it a smaller number, so it's a positive exponent. If it's a smaller number that I'm making into a larger number, it looks larger when I have it written, then that means it's a negative exponent. All right, let's go ahead. We're going to try a couple more of these. So write 7 times 10 to the negative 2 in standard notation. So we have our notes here again. So these are the same notes as the last one, but now we do have a negative exponent, right? Negative 2. So here's my 7 point. And since it's negative, I'm paying attention to that exponent. I'm going to move it to the left because that's the negative direction. 1, 2. So I'm going to put a decimal point there, and then standard decimal form, I'm going to have that 0 on the front. So it's not just 0.07, it's 0.07, but this 0 on the front does not count as one of your movements. Be careful about that. All right, so now we're going to write this one into scientific notation. So we have 0.00259. This is definitely a very small number. And so again, we have our pieces here that I still need to fix because this is a typo just like on the last one. So there was our number that kind of popped up there. So I'm going to move this decimal to the right until I have one number to the left of the decimal. So it's 2.59 times 10. And since I moved from the left, it's a -3. And again, it's a small number, so that should be a negative exponent. If it's a large number, it should be a positive exponent. All right, so I think that'll be it for this one. And then we'll do a word problem on the next one. So I hope that helped, and I'll see you on the next video.